How many of you are there? Ma'am, good afternoon. Raki ma'am?
Good afternoon, ma'am.
How many of you? Only?
Only I am there.
You are there. Yeah, let us wait for a few more minutes.
Okay, ma'am.
Okay, we'll wait. Ma'am, let us start.
Yes, ma'am.
Okay. Yeah, we were about to start talk about the gravitational settling chamber, isn't it? This is quite technical part. People have to understand. But at the same time, this is important lesson also when you are studying environmental sciences. One second, please. Okay, gravitational settling chamber means it's a kind of device, or I can say it is not a device, a equipment, which is being used to collect the particulate matter from any generation point. And by natural gravity, it is settled down by reducing the speed of the flow or reduce the speed of the gas stream inside the chamber. Then it is settled down by its natural gravitational force. So how the unit, how it's it working, we'll see. I think I have not included a diagram. I feel. Let me check. Yeah. Yeah, it is there. You can open the sixth slide. The diagram is there. I will explain. Don't worry. Actually, basically, this gravitational chamber is a long chamber. The diameter should not be more, but the length should be more. It is called a long chamber. You have to select like this. Then whatever the gas you have to clean from the particulate matter, you just passes through the chamber. And once after entering into the chamber, you have to reduce the speed of the gas stream. And when you are reducing the speed of the gas stream, what will happen automatically due to the natural gravity? Whatever the particles are there due to the density difference, and also by the gravity pulling, it will be settled down at the bottom of the chamber. Then you can collect it. Once you stop the flow of stream, you can discard the particulate matter, which may contain dust particle, grit particle, even unwanted any liquid droplets, solid droplets, along with that soot particle, everything will be settled down like this. Anything, it could be solid or liquid particle suspended in the gas stream. Whenever the gas stream enter into the gravitational chamber, the particles are the entire stream of the gas which has some particular velocity. When the particle, whatever the particles are present, a liquid or solid particle present in the gas, when it reaches the terminal velocity or terminal free-falling velocity, which is proportional to the square of the diameter of the unit, as well as the density difference between the particle and the carrier gas, which is inversely proportional to the viscosity of the carrier gas. This is a kind of equation which is developed by the Stokes. The law is called the Stokes law for the small particles or fine particles. This is the specific law developed to settle down the fine particle from the gas stream. So the particle diameter, square of the particle diameter and the density difference between the gas stream and the carrier gas upon viscosity, inversely proportional to the viscosity of the gas, which is directly proportional to the terminal free falling velocity of the gas stream. When it is like that, whatever the solid or liquid droplets are present in the gas stream which you want to purify, from that the particle will be settled down. What is meant by carrier gas? Any one of you know what is meant by carrier gas? Carrier gas means when you are sending the gas will come at very high temperature, first point. So it's supposed to be cooled down little. So for that we cannot, anyhow, any exhaust or any chimney gases, if you look means they are reducing the temperature to some extent, then only they are discharging. Directly we cannot discharge. We directly means the temperature was around 800,000 degree also, it is not at all possible. So they bring down the temperature half of that or less than that, then only discharge. Here all the same thing is happening. And when we wanted to maintain the flow throughout the system uniformly, and it's supposed to carry the analytical gas throughout the unit uniformly, and we have to maintain the same terminal free falling velocity. Something must be carry inside the unit. The carry means the along with the gas stream, whatever you want to clean it up, along with that we have to send some other inert gases like helium or nitrogen. Though that kind of gases we have to send, that comes along with that sample and carrier gas both comes together inside the unit. Any carrier is a gas, it will not do any activity on that. Only thing is there we are increasing the volume of the input gas. At the same time, we are allowing to reduce the speed of the gas inside the unit. In such a way, it meets whatever the required condition according to the Stokes law. Then the particle, whatever is present in the gas stream, will be settled down. Here, the cross-sectional area of the settling chamber must be very larger than the inlet duct. Then the pollutant gas stream enter into the settling chamber. That device which has the specification that cross-sectional area where the gas stream is passing through, that cross-sectional area must be higher than that, whatever the inlet duct where the gas enters. Then the gas stream containing particulate matter is allowed to flow at a low velocity inside the sampling chamber. And we have to allow the particle inside the sampling for some time. It is not just passing inlet, it enter and outlet, it comes out. No. Once it enter into the settling chamber, it allows for some time to be inside. Because there we have reduced the speed. Then the gas will be returned for some time inside the chamber. Then whatever the liquid and the solid droplets are there, that will be settled down at the bottom of the unit by the natural gravity. That's what this is called, gravitational chamber. Okay, you can look at the diagram in the sixth slide. There are different types of settling chambers, horizontal, vertical, many things are there. But I am going to tell about only one. The horizontal floor settling chamber, it is showing in the figure. You can see at the left side, the inlet gas is there. Then you can say one duct. That duct area should be less than the whatever the cross-sectional area in rectangular shape. That shape should be larger and the duct shape should be less than. Then you can see the gas outlet. At the bottom, you can see the dust hoppers or dust collectors or dust hopper, whatever it may be. After entering the gas inside the rectangular shape chamber, which is not directly coming and going, it is allowing to stay sometime inside that chamber. And also the speed of the gas is reduced. After some time only, we have to open the gas outlet, or you have to provide little longer horizontal time. Then the flow is maintained in such a way, very small or very less velocity. Then it could be retained and system can be working continuous also. Like that design also is there. Batch type also is there, continuous type also is there. In such a way, the system is working to collect the dust particle from the gas stream which contain lot of particulate matter. Okay. And the next type of Howard settling chamber. This is some kind of when we wanted to increase the residence time inside the unit. Then they are making some different type of plates inside, and we can say this is called one specific name is there for that. They are providing some of the duct or tray. They are saying. When we are providing the duct on tray, and at the corner of the chamber, we have to provide the gap. Then the gas is entering and moving in a zigzag manner from here to here, like that zigzag manner. When it passes through like that, whatever the solid liquid droplets are there, that will be settled down according to the natural gravitational force. And the clean gas is existing at the right side of the chamber. This is also in practice. Only the difference between this and two, this Howard type will occupy less space, but the horizontal type, it occupies very larger space. And efficiency wise, the second one only gives more than the first one. And in Howard type settling chamber, the horizontal trays will be fixed in the chamber at about 1 to 3 centimeter height interval. It is not much height. Then the flow will be narrow. Whenever the flow will be turned out, any fluid flow will be reduced. Then when the flow is reduced, flow speed is reduced, then automatically any dense particle will try to find out the way to settle down. It is normal phenomena of science. The increase in the efficiency of the Hava-type gravitational chamber is depend upon the number of trays, and maximum 5 to 7 only, 7 trays only we can increase in the Hava-type. More than that means again that will take longer time. If anything could be cooled down and it is settled down on the settled on the tray means that is not good, because some of the hydrocarbons gases, if the temperature is falling, then it may be condensed. A condensed form of hydrocarbon will be sticky form. Then those sticky form is quite difficult to remove. So we have to be careful when we are doing this process also. Maximum we can use 7 trays only to get the maximum efficiency. So this is about the gravitational settling chamber. You have to remember 3 points. According to the formula, otherwise according to the Stokes law, the Stokes law, which is developed for the fine particles removal from the gas stream. According to that law, when the free falling velocity is proportional to the diameter of the particle and the density difference between the gas stream and carrier gas and inversely proportional to the viscosity of the gas stream. When this thing is approached, then automatically whatever the particles are there in the gas, and when it after entering into the chamber, when we are reducing the speed of the gas and we are allowing some time to be written inside the chamber, then automatically the law will be satisfied. That time the liquid or solid droplets will be settled down at the bottom. You can repeat the process by batch reactor also, or it is continuous reactor also. Only the difference is batch means we can reduce the horizontal duct length. If it is continuous means you have to increase the length of the duct. Always in such a process, the length of the duct, length of the horizontal chamber must be greater than the duct width. Because when it enters, the speed must be more. Once it enters into the speed, then the surface area will be more, mean the horizontal velocity will be reduced. So in such a manner, we are allowing the time to stay inside. This kind of unit is being used to remove or settle down this kind of particles, especially from the quarries. Quarries means from the rock, whatever the things people are taking, like granite, like that kind of stone related things, wherever people are extracting, they are using it. This is not very huge unit, and this multi-type also people are using many times. When it passes through, only thing is they have to find out the way where it comes out, how it goes out. Again, it is coming and settle down and mixing with the process itself means it is not a good practice to eliminate the particulate matter. So entire process where it exhausts, from the entire exhaust it has to be connected, then the total gas stream will be purified from the particulate matter. Okay. Then the next one is, my God, always I'm doing like this. Cyclone separator. Cyclone separator is one of the important unit, and the wonderful of this cyclone separator is, if you want to separate any solid or liquid from the gaseous stream, we want to separate the solid also or liquid also, you can use the cyclone separator, which is like some of the cone shape. From the top, we are introducing the gas, and which makes the wireless motion inside the cyclone separator. You can look at the diagram, you can understand. When we wanted to make this wireless motion means, we have to introduce some sort of spiral motion inside. When it makes the spiral motion inside, obviously the particles are also making the same pattern of motion. Once it happened that at the top it enters, in the middle which undergoes the spiral motion, then the suspended particles will be forced towards the wall of the middle. It won't collect, it won't directly go into the bottom and from where we can collect. No, this is something different. When it gives the tangential inlet, that means through the motor only we can enter the particle. And when it enters, it makes the swirling motion. When it reaches the swirling motion, because of that speed, whatever the solid or liquid particles are there, that is go and deposit on the wall side. wall side. The process will be continued. Once the process is over, and we can scrap out whatever the deposited particle on the side, then we have to remove it. In such a way, this cyclone separator is working. Now we'll see what is there in your book. In a cyclone, the particle ladder gas is accelerated through a spiral motion, which impacts centrifugal force to the particle. We know that what is centripetal and centrifugal. So that makes the substance to be in a spinning. The centrifugal force forces out the particle from the spinning gas and makes them fall on the wall of the cyclone separator. So when it is fall on the cyclone separator, from the high speed, because the gas stream enter into the cyclone separator by a kind of motor. We have the motor kind of thing. When it rotates, the gas enter inside. Once it enter tangentially inside the cyclone, which makes the whirling motion. This looks very wonderful. I worked on it. Then when it makes like this, the particle, whatever the particles are there, it will go on the speed on the walls of it, because that does not have any space to escape. So there is only the possible ways. When the motion is there, the gas will go down, and these things will be settled down. The liquid and droplets go and hit on the walls of the cyclone separator. Somewhere, if the temperature is more, means it makes stick, and it will be settled down on that side only. Then what will happen? The gas enters the cyclone through the tangential area and an inverted cone attached to the base. The gas enters the cyclone through the tangential, which imparts a whirling motion. Suspended particle will be forced toward the walls on which they collect and slide down into the conical separator near the part. So whatever the particles which is slide down on the wall, and over the period of time continuously when the unit is running, those particles will be falling onto the bottom only. Then the continuous gas flow, continuous motion, continuous settling, and the continuous falling of particle is happening. All the cyclone separators are working under continuous mode. If we want to stop, we can stop it. Otherwise, the system is working continuously. Okay. There are three types of cyclones are generally available for industrial use. One is high throughput cyclone, second one is conventional cyclone, and third one is high efficiency cyclone. High throughput means the input should be more high. Conventional means normally whatever the things without any special feature. High efficiency means with the optimum level, with less energy consumption, more output is working. That means whatever the gas stream you are sending inside, according to the speed of the motion, speed of the input, that will be passing very fast, and its falling rate is also high like that. The efficiency of removal is not only a function of the size of the particle, it depends on other variables such as airflow and the size of the, size of the core, and the distance between the input and where it makes the swirling motion. That is not in your book, it is noted on those points. Based on these three factors only, the efficiency of those things will be changed. And you can see the diagram in your book or in the slide also, it must be there. I think I have not added or not, I don't know. Cyclone separator title is there, but the diagram is not there. You can look at that, one cone will be there. Once actually this is the cylinder. At the bottom of the cylinder, one cone type is attached. And from one side, inlet will be there, and another side, outlet will be there. The gas enter into the cyclone by the motor at very high speed. That's what suddenly when we are putting and leaving in a closed container means the gas flow is making in a spiral manner. And when it makes the high density and solid liquid particles will be or slide on the walls, then the gas released parallel to the input, outlet will be there. Through the outlet, the gases escape. The high dense particle will be settled down at the bottom of the cone. So the cone is designed in such a way which gives the space to settle down the particle, and there is a provision to exit also to collect the particle. Okay. In such a way it has been designed. And another one is electrostatic precipitator. Among these three, any one question will come. The electrostatic precipitator, which is working based on the electrostatic charge, and there, if you give the charge, means there will be a generation of electrostatic field. Then when we are giving like that, the particles will getting the charge. then there will be a potential will given, potential field will be there. Electrostatic charge, if you are given, the principle of this particle is, when we are giving the input, the charge, the particles are getting charged, and it is driving them, and they will collect, when the particles are getting charged, it means the walls are not getting charged. The walls of the electrostatic precipitator unit does not have the charge. So the particles will be fallen. Then if any negative charges is there, it will be stick. Otherwise, it will be falling. That is the concept. A gas stream containing suspended particles is allowed to pass between the two electrodes, which is electrically insulated from each other, and between which there is a considerable difference in electric potential. Whenever there is a electric potential difference, then only the particles will be getting charged, because potential difference must be there. If it is same potential, then there will not be any active anion and cation must be active. So to make it, we have to give the potential difference. The high voltage electrode usually has a cross section and some curvature area. It is very fine, small wire like that. That is, the high voltage on the electrode of small cross section ionizes the gas and aerosol particles. Once it is ionized, hey, what happened to me? Once it is get ionized, then corona is formed. That is the core area where the potential is very high, and the is formed of all the ions are very active, and that is fully charged. And this corona is formed of ion which attach to the particulates. Then that particulates make them to ionic. Already you have the one wire. There you are giving more charge, high voltage. When you are giving high voltage, that will makes the ions. That is called corona. Then those corona ions, when we are sending the gas stream, whatever the particulates are there, that make them to ionize it. Now all are charged particles. Then these particles attached with the corona ion particles and attracted to the large electron electrode, everything all together, both the corona particle as well as particulate matter, both are collected in the electrode. The positive particle will go to the negative electrode, negative charged particle will go to the positive electrode. Then they are allowed to flow down or drain by gravity and collected at the bottom. When these particle, opposite charged particle when collected, then the particle will become saturated. The saturated particles will not be attract further. So once again, in the whatever the wire we are putting inside, again and continuously charge, it gets charged. Continuously it is emitting the corona, and continuously when you are sending the gas stream, whatever the ionized particle are charged particles are there in the gas stream, it undergoes the same concept of attracting with the corona particles. When it reaches the saturated, it will become inactive. That inactive material particles are settled down at the bottom of the electrostatic precipitator. Then it will be collected. It is more efficient on smaller particle than the gravity settler and the cyclone separators. I think I told you or not, I don't know. The particles of size 1 micron to 40 micron size. The particle size of what particle matter size? 10 millimeter to 0.1 millimeter. In that, very fine particles of 1 to 40 micron, very small, that cannot be even collected in the dust collector also, I said. But in this, because this is working based on the electrostatic potential, so even small size, because here the size of the particle does not matter. Only that whether it has potential or not, and electrically it is active or not, that only is a matter. So the particle, when whatever the particles are active, which is attached with that corona formed ions, then it will be settled down at the bottom. So very, very small fine particles also could be separated by making use of this electrostatic precipitator. There is a diagram in your book, you can look at that. There is a power supply, they are giving power supply to the wire which is in the middle. And when the gas stream is enter inside from the right side, you can, left side you can enter. So once it is get charged, then it started emitting the ions, and the gas stream when it goes, these two are reacting, then it is attached to each other. When it is attached to each other, it is reaches to the saturated condition or inactive condition. Those particles will be settled down at the bottom, and the clean gas will be exhausted from the top right side. This is the principle involved in this electrostatic precipitator. About this, some other things are intermediary energization, how it works. Some of the principles and effects are there. You people can go through it. Because it is important, and we cannot say that is not important, important only. Okay, intermediate energization, what will happen? Intermediate energization is an energizing which before the voltage across the dust layer, which exceed the back corona start voltage and reorganize or re-energizes when it turns to the original level. Therefore, electrostatic precipitator can be operated under the condition of supporting the back corona by the energization control. What is that way intermediate energization? When we are continuously operating this unit, suppose we are sending fresh ions from the gas stream, but the corona, whatever we have, that is whatever the energy which is supposed to give to the dust particle, sometime it may be takes time to re-emit the ion continuously. That is called re-energize, and that can be possible. And whenever we are doing that, then a restart, or again we have to go back to the starting point to give that much only. The small disturbance will come, and that's what which work under the condition suppressing the back corona by this energization control, which makes a small distance, but it will perform. So re-energize means what you should understand, that nothing more is available in this. What is that? I have entered two types. What is pulse energization? This is an energization method which repeatedly applies the instantaneous and high step voltage to ESP. Previously, we said once continuously when it operates, there is a possibility to go down the thing. That time that intermittently they are giving energy, that is called re-energization. This pulse energization means what? Repeatedly applies the instantaneous and high steep voltage form. So the high performance of electrostatic precipitator has following characteristics. That is, current density distribution of the collection electrodes can be uniform, and high peak voltage can be energized more. So the collection of particles must be more, the separation of particles must be more, which gives more efficiency than the another type. Application of pulse energization system, how they do this intermittent and pulse energization. Because of the two problem, intermittent and pulse energization, instantaneous power supply can greatly improve the collection efficiency when dealing with the high resistivity dust. It is more suitable for coal-fired boilers and sintering machines. It could be used with the existing electrostatic precipitator to improve its performance, as well as new electrostatic precipitator for the utilities and the industrial fields. So I think electrostatic precipitator for principle it is working. When they are working, they are doing two concepts. One is intermittent energization and pulse energization. Intermittent energization means when the pulses voltage is dropped, the corona of ions in the corona will be going down. That time also it could be energized by giving voltage. Then there must be a little voltage saving and the continuous operation at less energy input, which gives more efficiency. And the second one is instantaneously they are giving power when they are doing the same separation process. That also gives more removal of particle, they are telling. Advantages of electrostatic precipitator is pressure drop and hence power requirement is small compared to the other devices. And this is economical and very simple to operate because everything is ready-made. You have to do only on-off switch. Nothing else you have to do. Once you have to feed the gas, first you have to on the system, then that pulsation we have to give. Pulsation means power supply. Power supply, after giving power supply, that is started ionized. When the ionization is over, then you have to pass your impure gas. Then whatever the reaction I said, that attraction and repulsion is taking place, the particle become inactive, then it is settled down at the bottom. This process is being done in both the status of intermediate and pulse ionization concept. When we are doing like this, the power consumption for that particular unit is less when we are compared to the other types of operator. Because in cyclone separator also we need to supply the energy. One is we have to supply the or enter the input gas, whatever it goes into the cyclone separator, which makes it that much wireless motion or swirling motion means we have to understand how much speed we should give. So there is a device to inject the gas stream inside the compact cyclone separator. It is a cyclone means it is a cone at the bottom, at the top it is a hopper type, but it is in cylindrical form. When it enter into the cylindrical form, it makes separate whirling motion. Then you can imagine how much speed we should give. Water means it's okay. Gas means solid means it's okay. When we wanted to make the gas in a swirling motion, it is quite difficult. We have to increase the speed in such a way. In such a way, it makes the swirling motion means the pressure must be very high. Then only it makes the flow of such a pattern. Then only it will be settled down and slide down on the walls of the cyclone. Here, so that energy, and we know what is that electrostatic precipitation, another gravitational settling. Gravitational settling chamber, you no need to give extra energy, only we have to give certain energy at the inlet of the chamber. After that, by the natural gravity only, it settled down. But efficiency is okay. When we are operating at the continuous flow, that also gives better efficiency, but this electrostatic precipitator can be used to settle down the fine particles. But gravitational chamber cannot be confirmed like this, because gas density and the particle density both are same means it will not be settled down. It goes along with the gas. But here it is not like that. Based on the potentiality difference, it is working. So any small particle also can be observed and can be attached with the corona, and it can be settled down at the bottom. So 99% efficiency obtainable. That means that is possible. Very small particles can also be collected both in wet dye and dry format. 99% the concept of this vacuum cleaner, this is working in the same concept. Either the particles are in wet or dry format. But there we are providing the vacuum to suck, and the remaining things are similar. And it can be handled both gases and mist for high volume flow, and it can be operated at a high temperature and pressure. I think if people would have understood, this is one of the important questions. Then gas filtration particulate removal. Because nowadays, now we have spoken about the equipment which can be used in the large scale industries like cement industry, and they have given some of the industry like a thermal power plant and all the sintering type of industry. Sintering means all ore related manufacturing industries only. Those industries are making huge amount of dust and particulate. There it has to be used. Otherwise, the people, those who are working inside the environment also become quite difficult to survive for a long time. Because one or 2 days the dust goes means we are used to cough and we are saying that this I got, that I got. But when we are doing filtration, whatever the settling chamber we have discussed, they are using some of the filters also to filter out this kind of particulate matter. For that, they are using 2 different types of filters. The 2 main types of gas filter are in use for the removal of particulate matter from the industrial gases. One is packed bed or depth filter. Second type is fabric elastic filter. And the performance efficiency of any filter is determined from the following criteria. That is how the pressure loss is there, how the collection efficiency, lifetime or dust holding capacity. Based on all those things, the efficiency of the filter media is being decided. And classification of fabric filters. There are 3 different types of backhouses people are using in the fabric filters. Classified, basic fabric filters, based on the method of cleaning. And there are three different types of back houses. One is shaker, reverse air, and another one is pulse check back houses. From the name itself, we can understand how the system could be worked. Here, we can see the diagram. The diagram is clear for you people.
Yes, ma'am. Okay.
So here the back house means what? Back house means what could be the meaning? Anyone can tell me? It is a kind of filter. Filter means what? What you are doing the coffee filtering, the same thing. In the coffee filter, you are separating out liquid and solid. In the gases filter, we are separating out solid liquid from the gas. That is only the difference. It could be solid or it could be liquid particles, fine particles, and we are separating out from the gas stream. Why they are saying that this is a back filter? What is the reason behind that? Why it is called a back filter?
Collecting. That's it.
Yes, yes. If I alone speak, it won't look good. Then I monotonically, I only will speak. Yes.
And they are collecting it.
Collecting it. Okay, good. Then. Yes, correct only. Actually, we have some of the compartment wise. Now, when I was talking about this gravitational settling chamber, they have introduced the many trays, I said. When we are introducing in the trays, which makes the flow of the gas in zigzag manner, because it enters and it goes at the end of the one plate, then it comes back and again it comes back to the gap between the first and second tray. Then it enter into the gap between the second and third ray. Like that, it moves a zigzag motion of the gas. So the residential time of the gas inside the chamber is more. So whatever the particles are there, it is settled down little more quantity. So settling velocity must be more. Here what we are doing, here also we are doing the same thing. They are making the path which flows through. We have to, the gas supposed to be enter into the one filter. How we can define it as going to the one filter only? We make the provision that gas pass, because here it is a filtration phenomena. How much area of filter is being covered, and how long it is retained on the filter space, then only the efficient filtration must be taking place. Here the surface area accumulation or the surface area occupation of the gas stream is very important. So only one filter we are making, and through that we are passing made. We cannot assume that all the things can be filtered off at that time. At that time it is very important. So what they are doing, the filters they are make it as a small compartment, and all the compartment they put it in a one big container or a device or hopper. Then the gas flows is making in such a motion, and we have to give some shaker kind of mechanism. Then the gas will be, whatever the gases are going inside the each bag or container will be shaked little. Then the movement of gas will be little faster, or we can get little agitation. And when it goes, there is a hopper. Through the hopper, with the gases are entered. Due to the, again, the density difference is a concept. And we are providing small shaking mechanism inside it. The solid particles will settle down at the bottom and the clean gas will be coming out at the top of the filter. So this is very common type of unit is available everywhere. It is not very big concept is being adopted anyway. Okay. And spray towers are very important. And the remaining thing of this filters, if you go through the diameter, pressure, and what is the dust collection rate, these and all the people generally will explain the physical parameter. You just to go through it. Okay. And the next one is spray towers. Spray towers are very important. And when the subject knowledge wise also it is very important. And exam point of view, it is okay. Sometimes they have asked the question, so not continuous manner, but sometimes what is the venturi scrubber they have. Spray towers, scrubbers, there is no much difference. I will explain what is spray tower and what is scrub.
కింద పడేస్తావురా
Who is there?
పట్టుకోనిలే కింద ఎందుకు పెట్టావు ఉడికే నా క్లాస్ అయిపోయింది
Hello. Who is that? Please mute yourself. If I mute, it won't look good. Okay, spray towers. Spray whenever the term comes. You have to understand that we are giving the pressure to the solution. Then it makes the speed and pressure on the, not solution, on the fluid will be more. Okay. Again, I am saying spray whenever the term is coming means either by mechanical or manual or electrically we are giving some pressure that we are giving some force, that is in terms of pressure we can say, because pressure is force per unit area only now. Then the flow of any fluid will be at very high pressure and temperatures. Wherever the concept is applied, there the spray concept term will come. So here in spray towers, the people are using the water. How they are spraying the water through nozzle. And what will happen? Whatever the gas stream, we are going to clean it up. That enter at one side. And we are spraying the water from the top. And there will be a possible of counter current motion. When the counter current motion is happening, the particle to water interaction is happening, that gaseous molecule cannot react with water directly until or otherwise it is soluble, that will react, that condense. If that is the case, the condensed matter also will be settled down at the bottom. The insoluble flue gases that will be exhausted from the top. What is meant by counter current flow? Can you say, any one of you? There are two types of flow. One is counter current flow, another one is co-current flow. From the name itself, we can understand what is meant by co-current and what is meant by counter current.
Against the direction of the flow.
Yes. If both are same direction, two fluids are flowing in the same direction, that is called co-current. Ma'am, that is correct. The flow of two fluid direction is opposite, means that is called counter current. Here the gas is, the polluted gas is entering at, there is a chamber. Chamber means it is a kind of hopper which has the provision bottom. At the bottom, one outlet must be there. That is for discharging or discarding the waste or slurry. At the side of the bottom, you have the provision to enter the polluted gas. At the top side, you have the provision that to enter the or spray the water. At the top of the unit, you may have the provision to exhaust, to collect or to send out the clean air. These are all the part of that spray towers. So here, when the spray tower is there, where the water is introduced through the nozzle, and which direct the spray towards the bottom of a circular or rectangular chamber, and the polluted gas is entered at the bottom and it flows through the dust particle, and which collide or react. Collide only is correct. React means it makes compound. Collide with the liquid droplets which is generated by the nozzle spray. Then because of the interaction between these two particles, the particle density will be increased. Then the particle will be settled down at the bottom. The liquid droplets and they capture the dust particles, and which is impinging on the water eliminator and are removed from the gas stream, and the clean gas is exhausted from the top, and the water mixed, condensed, impinged particles will make it something like a slurry. Both liquid and gas solid will be collected in that, which makes a slurry. The slurry will be settled down at the bottom. It could be discarded easily. Okay, this is about the spray tower. And the next one is about the Venturi scrubbers. Venturi scrubber is one of the important question. Only few lines must be there in your book about the Venturi scrubber. You try to make it as a point one by one, and make it as a point and write it. And this diagram also you please note, draw it. Then you can get this full mark. Before that, 1 or 2 points you have to write about the scrubbing. Scrubbing means what? Anyone can tell me, please? What is meant by scrubbing? There are
Removing from the surface.
removing from the
Dirt. Removing dirt from the surface.
no, ma'am.
Using method.
That is common term, okay. This scrubbing technology, removing that unwanted things or dust from the surface, that is also scrubbing. That is correct. Very good. It is a common English term. When we are studying a technical thing or scientific thing, what is meant by scrubbing? Yes. That is English term, it is correct only. And they used the scrubbing technology, scrubbers, scrubbing principle. How this spray tower is working? What is the disadvantage of this spray tower? Can you tell me, please? I told you how the spray tower is working. The spray tower is working based on only the impinging principle. Yesterday class you didn't attend. Impinging principle means whatever the gas streams are there, whatever the soluble matters can be solubilized in water, and the remaining things will be exhausted. That is called impinging principle. That could be what the solution could be water or any solvent, anything could be. Whatever the waste stream is coming into the impinger, the solubilized things will be collected in the solvent media. The insoluble gases component will be exhausted. That is called an impinging process. Impinger means what? It is a kind of glass bottle. There are two mouths in the same bottle. One is for inlet and another one is for outlet. Through the inlet, the gas will be entered. Through the outlet, the gas will be exhausted. When it enters into the impinger, that is a glass bottle, that bottle we have to provide the solvent or water. Water is also a solvent now. That's what sugar and salt is dissolved. And when we are doing, the inlet should be provided till the end, bottom of the bottle. It should not be touched the bottom of the bottle, but when it is about to touch the bottom, like that, it has to be provided. But the outlet should be provided at the top only. There should not be any tube which would enter into the collection medium. Collection medium is water or solvent. The inlet should be dipped into the solvent. It almost touches the bottom, but it should not touch the bottom. Like that, we have to provide the tube. But the outlet should not be inside. It should be inside the bottle. It should be just above the solvent medium. So what will happen when the gas enter into the solution? It will be solubilized inside, whatever the soluble matter. The insoluble matter will go up of the bottle content. Then there is no space at all when the continuous process happening. Due to the density things and insoluble nature, the pressure occurs, then it goes out through the outlet. So this is in series they are doing, not with a single impinger. They used to use 3 to 5 impinger bottle, and if any hot gases are coming in, all these impinger bottles are being kept in the water bath or ice bath, like that in chilling condition they are making. So here also this spray tower is working based on the impinging concept only. The water droplets are coming through the nozzle, it sprays at very high pressure, and the gases are also entering from the bottom at a very high pressure. When flows are occurring from the bottom to top and top to bottom, both are collide at the middle portion. Then when their terminal velocity is being reduced, when it is reduced, then it changes the medium. The gas, whatever the gas droplets, whatever the particle can be converted and condensed, it will be condensed. And some of the solid particles will be dissolved and it solidifies and it settle down. That's what we are collecting the impurities in the form of slurries in spray towers. Now you please tell me, spray towers are also using to settle down the particle through the water spray, and scrubbing technology also working on the same concept. What is scrubbing technology? Scrubbing means you are sending the hot gases and to separate the solid or liquid from the gaseous stream by reducing the temperature, and we can separate it or filter it off. That is called scrubbing technology. That is removing of dust or liquid dust from the gaseous stream by reducing the temperature and reducing the speed, and the particles will be settled down. That is called scrubbing technology. This scrubbing technology, there are different types of scrubbers. The unit used for the scrubbing technology, they are called scrubbers. There are different types of scrubbers are available. One is centrifugal scrubbers, venturi scrubbers, packed bed and plate column scrubbers. And these are all the common types of scrubbers are available throughout the world. Specifically, scrubbers are being used in many applications. Okay, now what are the now you tell me what are the you know what is meant by scrubber now. You know how these spray towers are working. What are the disadvantage of this? Or I can say it is not a disadvantage. I can say what is the drawback of this spray towers.
Here there is no unit where hot gases will be cooled.
Okay. No need to do also, na?
But if hot gas will go, then unit may blast also.
Yeah, they made the design in such a way, no? Suppose if you are talking about the thermal power plant, we know what is the process temperature at what times of two gases will be existed, isn't it? The exit or flue gas temperature, they might be knowing. Then they are designing the unit for scrubbing or spray tower in such a way. The 600, 700 degrees centigrade, the gas enters, you are spraying the water at what temperature? You cannot use hot water, no? You can spray only the water at room temperature only, isn't it? Yes or no? Water could be sprayed at what temperature? Only at room temperature, isn't it? Hot water you cannot spray. If you spray hot water also, what will happen? It's supposed to cool down the gas. When it cool down the gas, then only density increases. Then due to the density difference only, the particle will be settled on the bottom by the gravitational force. That is common phenomena everywhere. Okay, now in this particular case, I said how this, now only one question I will ask you. Everywhere we have studied that the particle will be separated, clean gas will be coming out. But here it is possible that the gas could be clean or the gas could be wetted. Wetted gas are also coming out, isn't it? This is the concept, one of the concept is available in the world or in technology wise. We can separate out the solid or liquid particles from the gas. But when we are talking about the recirculation concept, a reusable concept, it is not useful. So for that only they have find out the next alternative. One of the alternative is scrubbers. Scrubbing is also a technology where it could be reduce the temperature and the whatever the solid and liquid you wanted to separate out, you can separate out. And the exhaust or exit gas combination composition will be reduced, but the physical property of that particular flue gas will not be changed. But in cooling the spray tower, suppose some hydrocarbons are there. All the hydrocarbons cannot be condensed at room temperature. And some of the hydrocarbons are highly volatile at room temperature. They may not be settled and they may be along with the gas stream. Then if it is react with the water, then there is a possible some of the alkanes can be converted into alcohol. And others, the many things are there. Any oxides are there, it will be converted into their respective hydroxides. hydroxide compounds are coming, the nature of the exhaust or exit gas will be altered. Whatever your treatment you are giving, either it is water or air, it should not change the nature of the substance. If it changes the nature of the substance, then the efficiency of the treatment will go down. But even in some of the process, if it reacts something and it gives us a second and third component, it does not matter, it won't influence on the process efficiency. It's okay, it's well and good, we'll go ahead like that. But everywhere it may not be the concept. That's what they are having for same technology, different options. Okay, now we'll talk about the Venturi scrubbers. Actually, gaseous pollutant, which some of them are sticky, some of them are toxic, and some of them are flammable. Many types of particulate matters are there. We are all knowing that. But in general, we know that particulate matters, they are very fine particles, very small in size, and this corrosive in nature, toxic in nature. Some of them are flammable in nature. Many types are there. All that type of particles can be separated out by this Venturi scrubbers. That is the advantage of this particular type of scrubbers, Venturi scrubbers. And this offers high performance collection fine particles, usually smaller than 2 to 3 millimeter in diameter. They are particularly suitable. These Venturi scrubbers are suitable when the particulate matter is sticky, flammable, or highly corrosive in nature. High performance of the Venturi scrubbers is achieved by accelerating the gas stream velocities of the order of 60 to 120 meter per second. Okay, this speed is very high only, na? Then the droplet accelerate in the throat section, and due to the velocity difference between the particle and the droplets, the particles are impacted against the slow moving droplets. And because of that slow moving like gravitational settler, that will be set, the particles will be settled down. And the acceleration continues to some extent into the diverging section of the Venturi. The gas liquid mixer is then directed to a separation device such as cyclone separator, where particulate matter is separated from the gas stream. Actually, in Venturi scrubbers, the Venturi scrubber cannot be used directly for removal solid or liquid droplet from the solid liquid droplet means is nothing but particulate matter, isn't it? From the gaseous stream. But this is the method can be used to do whatever the mentioned properties of gases of 2 to 3 millimeter size. When they are accelerating the speed of the flow in such a way that 60 to 120 meter per second, due to the high speed action and feed liquid is atomized and the uniform fashion across the throat through the several low pressure, it is occurring in the from the spray nozzle directly radially inverted in the Venturi scrubber. You can look at the diagram, you can understand that. We open the diagram. The inlet is there. You please look at the inlet at the left side, where the speed is maintained 60 to 120 meter per second. The mouth of the inlet is little wider and it is narrowed down to the duct very smaller with the cross section area. When the speed at the wider area is less, means when it goes to the small area, the speed must be increased, isn't it? Then the speed is increased. Again, the speed is decreased at the right side end of the unit. They are widening the area again. When they are doing this widening, again the speed of the particle will be less. Then it will be settled down at the bottom and the gases will be emitted. This gases, we cannot say 100% it is completely clean it up. Again, this gas stream is sending to the cyclone separator for complete elimination of all sort of particles from the clean gas. So the advantage of this particle, if we exhaust or if the flue gases contain toxic, flammable, corrosive gases or corrosive component means which will gives very serious effect on the environment or ecosystem, like human being, building, whatever it may be, which corrodes means corrodes only. If it corrodes building means definitely it affects all the living things, including plants and animals. So that kind of thing supposed to be collected before it is exit. So to remove such a particle, we have to introduce this unit And after collecting such a material, again it has to be filtered it off through the cyclone filter. Then it can be rejected or sent into the atmosphere. Okay, this Venturi scrubber is very important question, and they will ask in the big question also, knowingly or unknowingly, I don't know. The thing is, we are introducing at the high speed, reducing the speed. Sorry, we are introduced at the high speed, and because of that injection port surface area, the speed is reduced. Again, we are automizing to the high speed by reducing the surface area or cross-section area. And again, we are increasing the surface area by widening the path where we are providing more surface area to make the small flow. Then the speed of the fluid flow will be reduced. Either gas or liquid, same concept here. Then when the fluid flow is less means automatically the particle the fluid will be retaining in that particular area for quite a long time. When it is retaining like that, the already mentioned property particles will be settled down, but we cannot say that all the particle can be settled in this fashion. So again, the secondary treatment is required for that gas to exit into the atmosphere. For that, this Venturi scrubber coupled with the cyclone separator will be more effective to remove this type of particulate matter. Is it clear? Not clear?
Little
Yes,
bit.
madam.
No, I cannot understand. What is that? Little you are clear or no you are telling?
Little clear. Ma'am.
And another one, somebody else also replied. What is that, sir?
Clear, madam.
You are saying not clear. No, your voice is not audible.
Clear, madam.
Okay. Ma'am, where you didn't understand, please tell me. About the Venturi scrubber you didn't understand or scrubbers you didn't understand?
In Venturi scrubber means how surface area it is affected.
No, ma'am, actually, here the point is velocity difference is a point. Okay. We are making high velocity to low velocity. When you are making the horizontal flow is less, then the horizontal velocity also must be less. How we are reducing the horizontal velocity or horizontal flow here? You look at the diagram where the inlet is there, one section is there, and again the wider path is there. Clear? When the inlet is little wider, the section is very narrow, again the flow path is highly wider. So when we are providing the high surface horizontal area, automatically the flow will be reduced. Whenever the flow will be reduced, or the horizontal velocity also will be reduced. If you have doubt means, you do one thing, you take one bucket of water or glass of water. You just pour it on the ground. How it flows, just look at that. Then you take one bucket full of water, with the same fashion you just flow, you make it the flow on the steel plate, you make it the flow on the surface. You kept both are parallelly and observe it. The flow on the horizontal surface, the flow. Hello? Hello? Hello?
Yes, ma'am.
Anyone is having doubt or they are talking for them? I couldn't hear their voice properly. Here the concept is velocity difference is a matter. The moderate velocity to little higher velocity. From higher velocity to again we bring down into the less velocity. So when the velocity is difference means the flow rate also will be different. When the flow rate and velocity is different means the difference in velocity which makes the flow of any fluid will be reduced. So when the flow is reduced, the fluid is moving from one point to another point slowly. When it is moving slowly, whatever the things can be settled down, that will be settled down. Since it is gas, the gas flow fast, and the solid or liquid droplets will be settled down at the side. But even then, in this particular case, all the things cannot be possible. Still, it may carry something. If we follow with this along with the cyclone separator, will it give? It will give better results because the substances are highly toxic, corrosive, and flammable substances are present. Those substances only will be separated, make use of century scrubber. The concept behind that working principle of the century scrubber is pressure difference, nothing else. Or the pressure difference we are giving in terms of velocity difference.
Okay, ma'am.
Okay. Okay. Velocity difference means what? We are reducing the speed by what? Providing more surface area. Okay. Now I will tell you the same. If you take small river and big river, the same quantity of water depth is going in the depth of the water is 1 meter. You take 1 meter water is flowing in the small river. 1 meter depth of water is going in the wider river. The depth is same in both the case. Now you tell me, in which river the flow of water is more, in which river the velocity of water is more. And both the depth of the water is same, where the velocity plays role. Now you tell me. Small only.
velocity will
Why?
be-
I said the depth is same. When depth is same, in both the river 1 feet only. Or 1 meter also you can say, whatever it may be.
because of more pressure, it will move fastly. There,
That means you are telling that if depth more means the velocity, both the depth are same only, no? Depth and pressure is place. Depth is more and the pressure is more. Depth is less, the pressure is less, we know that. But here their principle is, if the depth is same, the surface area is less, then the velocity is more. The depth is same, surface area is more, then the horizontal velocity is less. Now we got it?
yes, ma'am.
Okay, then the wider area when we are giving, when you narrow the flow, the horizontal velocity is more. When we are widening the flow, the horizontal velocity is less. So when the horizontal velocity is less, because of the velocity difference between these two layers, suddenly you cannot, when you go very fast, suddenly you slow down your speed, you may fall down, no? The person who is going for running, they are started with the less speed. Then they are speed up their speed, increase their speed. Again, they will slow down their speed to reach the point safely. When they are running very fast, suddenly they stop, means they may fall down. Isn't it? Yes or no?
Yes, ma'am.
Like the same concept. If the horizontal velocity more from the sudden high to low velocity difference, it makes a particle to fall down. That is nothing more than that. That is, this is due to the inertia. But in your book, that term, they have not used the term inertia, I think so. That inertia term is well, but they have given the term impacted against the slow moving droplets. It is not impacted, it is, they should mention that inertia. Due to the inertia, the particle can be settled down. And this kind of application as this venturi scrubber can be mainly used in craft mill furnaces, metallurgical furnaces, sulfuric acid concentrators to remove the mist and dust. That's what I said, wherever the corrosive gases, wherever the flammable gases, wherever the people are polytoxic gases, there only this kind of venturi scrubbers people are using it. Because there we cannot use any, in this particular unit, just we are increasing or decreasing the speed of the flow. We have not used any sort of other assessment. Are you looking at that? That flow velocity assessment also by providing the structure of the unit. We are not using any extra provision to run it. If you take cyclone separator, if you take electrostatic precipitator, if you take gravitational separator, where some of the extra devices people attached with that to running the unit. Why? There will not be any corrosive problem. There will not be any flammable problem. There will not be any toxic problem. So we can use some other auxiliary units to run the new equipment. But here none of the supportive equipments they have adapted. because of the nature of the effluent gas. The effluent gas means that is waste gas. When it enter a particular speed, again it is reduce the speed, again we are decreasing the speed by constructing the structure of the unit. Clear? Not clear?
Yes, ma'am.
Okay. So then only after removing this toxic substances, for further cleaning or further purification, you can use the cyclone separator. If you look at another devices, whatever we have studied, there is a flow of provision for flow of water. There was a provision for flow of gas, or there is a provision for charging of particles. Many things many things are there as a auxiliaries, but here nothing could be. Only structure is a matter. It could be, it is not required. You have to construct the things in a metal. You can construct this in a concrete material also. It's okay, well and good, fine. Nothing will be in place. Only thing is, it's supposed to meet the required velocity. What could be the exhaust gas or exit gas quantity and volume and conditions, and what could be the exit gases quality and quantity it is required. Based on that, they have to design and construct. It could be carried out. But anyhow, we want to reuse it for the process, you should use cyclone separator. That is only the thing, mind it. Otherwise, it will be well and good in it. And the second one is centrifugal separators. Centripetal means what? Centrifugal means what? Hey, this is very common type. You might be knowing it. Yes. Now you understood what is meant by impinging. Impinging means what did you understand? It is very important nowadays. It is industrialized world now. Different types of industries are developed, and everywhere the pollution is being created, either liquid, solid, or gases. So whatever the terms and terms are technical aspect we are discussing, it is very important. Very, very important. Earlier days, that is useful for only the engineers. Now, for the general knowledge, we have many sources to study. Understanding of these concepts are useful. It will not be wasted. So, what is centrifugal scrub? Centrifugal means what? Centripetal means what? The force which is acting towards the center is called a centripetal. The force is acting out of the center, it is called centrifugal. Okay. Now here the people are using the centrifugal, which is working and the force is reacting and is spilling out of the center. How they are making? This centrifugal collector utilize centrifugal force and wet impingement principle. Wet impingement means what? When you are passing the, whatever the impinger bottle, I said the same concept. Impinger bottle, how it is working? The impinger bottle has some solvent or water. In that, the inlet gas is collected inside the water. And the bottle will not be filled up fully. Only half bottle or 1/3 of volume of bottle is filled with the water or solvent. The inlet pipe is inside the solvent. Outlet pipe is out of just above the solvent medium. So whatever the material or substances can be collected in the solvent medium, it is being collected, and the remaining things will be exhausted. This process of cooling down and collection of gaseous stream is called impinging. So the similar concept is followed here. When the gas is going in a centrifugal manner, and when we are passing the water inside, then which undergoes the wet impingement principle, then it is collected. That the collection is based on the light to heavy loading of all size granular dust. Light to heavy, that means what? Again, that density concept is coming into the picture. Then the dried dust particle impinge against the wetted peripheral surfaces, because when we are doing this process, the peripheral surface of the collector will become wet. then it reducing the re-entertainment of the particle into the gas stream. Then it will not be retaining more with the gas. Automatically that will fall down, no doubt at all. As the incoming gas is spun down in inlet cones, the water and collector solids are separated from the gas stream. It is very simple concept, but 100% we cannot assure that all the particles will be impinged, because the while motion is happening in such a way, when we are making this centrifugal motion, the forces which undergo the centrifugal motion, then particles will be attached based on the impingement concept. Then the water solid impingement, when it is happens, some of them it goes and go to the peripheral surfaces of the collector, but it will be re-retainment, means it will be coming out of the peripheral surfaces by the movement, but we cannot assure 100% that the impinging will be happening for all the particles. It will be impinged, some of them will be get away, but this is one of the methods to be adopted for separating the particulate matter. Okay, the next one is very, very important. In some of the questions they have asked a centrifugal separator scrubber also. Only one diagram, 4 lines are there. So you have to write the centrifugal scrubbers being used to separate the particulate matter from the gas stream. And you have to write 2-3 sentences about the particulate matter, particle size and properties. Then one of the there are different methods are available to separate this particulate matter from the gas stream. One of the important method is this. This method is working on this particular concept, and this is the concept and this is the output diagram you have to show like this. Then only you get the full marks. And another one is packed bed and plate column scrubbers. This packed bed column and this spray type is very common type, and it is also an efficient type. Here, how we have studied about that spray towers, similar concept will be applicable here also. But only one thing, here the column is filled up with some of the packed material. That is only the difference. The packed towers are very efficient absorption devices involving continuous contact of 2 phases. When the gas is coming from the bottom of the column and the water is spraying from the top of the column, when these two fluids are interacting at a particular point, that is called 2 phases interacting surfaces. Interfacial property or interfacial, that is called. When these two are interacting, then we know what will happen, the same impinging principle. Then those particles will be absorbed in the packed bed material, which will be collected by washing, and again the packed bed can be regenerated. So the liquid is distributed over the packing, which provides high interface surfaces area and flow down the necking surface in the form of a thin films or subdivided streams, which makes the system to be. This is about the plate column scrubbers. And packed towers are very efficient, I said. And how the packed column is working means, first the column is being packed with some of the inert material. The material is supposed to be inert. It should not be reactive. Otherwise, some other things will undergo inside. What are the inert materials supposed? When you have studied the filtration lesson in your water treatment lesson, you would have understood. What are the filter media they are using? Fiberglass, sand, coke, or broken stone. And they are using granite, granular, and bituminous coal. Coal means everything. Coke means which comes under the coal also. Okay, some of these are all the material being used for the packing material, and this packing material used behaves like a collection media otherwise. Then the polluted gas stream moves from the bottom towards the top through the upward direction, and water is coming from the top to bottom, that is from the downward, that is by the downward direction. Then the counterflow flow is occurring in the packed bed reactor or column or scrubber, and comes in contact with the scrubbing liquid stream, which is moving downward over the packing in a film. The water is coming from top to bottom, gas is going from that bottom to top. One is an upward direction, another one is a downward direction. Both will be collide or react or stay in the packed material. The packed material is providing at the middle or center of the column, and those column, these two material will be interact. Then what will happen? The gas passes through the packing pore spaces and capture the particles by the inertial impaction. Then the similar way it happens in the water from the water side also. Then it is observes and smaller packing increase the efficiency of the collection, but in shade does not affect the collection efficiency. Sometimes the packing tower encounter packing problem also. Then what will happen here? The gas stream passes through the packing pores, which capture the particle, and because of good mass transfer characteristics of the packing, the efficient collection of the fine particles by the diffusion is also possible. So like that, whatever the particle, please somebody mute yourself. It is end of the class. Somebody is interested. No, there may be a doubt section also. So by the diffusion also, some of the particles will be absorbed in the packing column. In such a way, the system is working efficiently, and the efficiency is depending upon the collection, but the shape of the particle does not matter. Sometimes the packing towers encounter packing problems. Oh, you wanted to move? Hello? Can you hear me? Okay. Then which can be reduced by employing spray to wash the packing or by using low density spears or by the agitation, then chemical foam packing. Many things are there to regenerate the material. Then it could be regenerated or sometimes it is possible to replace also. But the system would be run for quite a long time. This is one of the better method to be removed this.
Ma'am, shall we wind up the class?
Okay, ma'am, that's all. If you have any doubt, any one of you, you can ask me. Yes, we can wind up. Anyone has any doubt, it is open to everyone. You can ask about the both papers. Not only this paper, anything. These two paper or all the four paper also you can ask, no issue. Thanks to every one of you.
Thank you, madam.
Thank you. If you have doubt, you can ask me. If you want to clarify, you can ask me. Anything important need to tell, you can ask me. No one has any doubt, but I have doubt. Can I ask you people? Okay, then thanks to every one of you. All the best. Do your exam well.
Thank you, madam.
Thank you.